Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra I and II class. Um, all right, so we've been talking about functions. We talked about relations. We talked about domain and range. We learned just the basics of some basic shapes of functions, what they would be like. We learned that we can graph any function by choosing values for x, the independent variable. We learned about the domain, the restrictions, remember? Pretty much domain is all real numbers except when there's a variable in the denominator. We got to set that expression to 0. If there's a variable inside of a radical in the numerator, we got to set that inside of the radical to greater than or equal to 0. Good job. And if we have an x inside of a square root in the denominator, we got to set that value inside of the square root to greater than 0, not equal to, greater than. Very good. So we've learned a lot. We know how to read a graph, and we know function notation now. We know f of x equals y. We know that when you see f of x or h of w or t of c, we know, for example, t of c would be function t with independent variable c. So we've done a lot. Today we're going to shift gears a little bit, and we're going to talk about compound inequalities. Think about a compound word. A compound word is two words together into one, right? Well, that's what a compound inequality is. It's two inequalities combined into one. Now, before I do that, I want to talk to you guys a little bit about sets, unions, and intersections, and you're going to see how it melds into what we're talking about today. Consider the following two sets of numbers. Set A has 1, 2, 3, 4, 5. Set B has 3, 4, 5, 6, 7. I think about it. No, I thought about this yesterday, and I said, how can I really make them understand this? So I'm hoping that I'm going to do a good job here and making you understand the differences here. If I tell you to list all the numbers that are in sets A and B, what would that set look like? 1, 2, 3, 4, 5, 6, 7, correct? That's all the elements of set A. Each value in a set is called an element. I should have said that before, sorry. Each value inside of a set is called an element. And a set is just a certain number of values, okay? So if I list all the numbers that are in the set A and B, this is what I get. Well, when I combine basically all of the elements that are in both, I have what's called an intersection. Think about it. An intersection is when two things connect, like the intersection of 87th and Coral Way. That's where Coral Way meets with 87th Avenue. They connect, they intersect. So when I list all of the values that are in both given sets, or all three given sets, however many sets there are available, when I list all the numbers in both that are in both sets, that is called an intersection. Okay? Okay, and actually, wait, this is wrong. This is wrong. I'm sorry, I shouldn't have listened to you. An intersection here. What are the list of numbers that are in both sets? 3, 4, and 5. Sorry, viewers out there, my class is asleep right now, and apparently I'm asleep as well, because I didn't pay attention. But I'm reading and I'm going, wait a second, that's not the right answer. Yeah, 3, 4, 5, that's where they intersect. Those are the only ones that are in both A and B. Now, that's an intersection. Now, if I take a list of all the numbers that are either in A or B or both, then that set looks like 1, 2, 3, 4, 5, and 6. Because 1, 2, 3, 4, 5 are and 7, thank you, are in set A, and 6 and 7 are in set B. So when you list all of the elements together, that is called a union. Think of the United States of America. That was a union of 50 states. So all together. So where am I going with all this? This intersection, the intersection of two sets A and B, which is denoted by this little symbol here, A with an upside down U, is the set of all elements that belong to both set A and set B. When they belong to both. That's why the intersection was 3, 4, 5. Because you got a 3, bless you, you got a 4, and you got a 5 in both. That is an intersection. Does that make sense? The word and implies an intersection. So when you see and inequalities, you'll see now what I mean by this. When you see and, you're talking about an intersection. Now the union of two sets, A and B, denoted by this symbol, A, regular U, B, is the set of all elements that are in set A, or in the set B, or in both sets A and B. The word or implies a union. Okay? So intersection, where do they overlap? Union, it's putting both together. That make sense? Okay, now, why did I talk about that? All right. So how does this work with compound inequalities? Well, compound inequalities consist of two distinct inequalities joined by the word and, which we already learned, and is going to represent an intersection, and the word or. Remember, or is going to be a unification, a union of two different sets of values. So I just wanted to kind of open your eyes to that. Now, let's see if I can do a good job here. Let's see. Because this confuses a lot of people. Hopefully this will not confuse you today. The graph of compound inequality, we're first going to talk about the ands. With the word and contains an overlap, that the ands are intersections of the graphs of two inequalities that form the compound inequality. So let me show you what's happening. I'm going to, my end result is going to be this compound inequality. X is greater than or equal to 3, and X is less than or equal to 7. That's my end result. Let's first start with graphing X is greater than or equal to 3. Okay, so bracket around the 3, right? And it goes that way. Makes sense, right? Now, X is less than or equal to 7. Bracket around the 7, and it goes that way. Is everyone with me there? Promise? Okay, now, bear with me here, okay? I don't know if this is going to work. Bear with me. Okay. When I have an and, it's an intersection, correct? So this is what's happening. I am basically intersecting here. Yes. Bam. Where do I intersect? Between here and here. This is the part of the graphs that overlap or intersect. Do you see what's happening here? So, how do I do this on an easier scale, Mr. Morrow? Because we can't magically move up our graphs like you did on the smartboard. Very simple. X is greater than or equal to 3. So it's going to go this way. But and X is less than or equal to 7. So that's it. I'm done. Does that make sense? I heard it. That's easy. Yes, it is. Good. If you read and if you know what you're looking for, you know that if it's and, you're going to be an intersection. It's going to be contained. Does that make sense, guys? And did that make sense, the example, how I did that? Okay. Now, this above example, you rarely are going to see a compound inequality using the word and. Very rarely are you going to see that. So you can rewrite the above compound inequality involving and as a single inequality, such as what I have right here. Now, I don't want to read it yet until I teach you how to read it correctly. Whenever you read a compound inequality, whether it's an and or an or, doesn't matter, you always read from the x. So what this is really saying is x is greater than 3, greater than or equal to 3, right? And x is less than or equal to 7. Does that make sense? We're going to do a lot of examples today, but I want to make sure that you got this. Sir? That's a great question. Is it always the smaller number first? It does not have to be. I like to make it that way. That way it's consistent in my brain. For me. Does that make sense? May I continue? Let's look at a union. Excuse me. The graphical compound inequality with the word or. So or, we're talking about union. So we're talking about a combination of two different sets. Contains each graph of two inequalities that form a compound inequality as well. The goal, to graph this guy. X is less than or equal to negative 2, or x is greater than or equal to 1. So let's first graph x is less than or equal to negative 2. X is less than or equal to negative 2, bracket to the left. Does that make sense? X is greater than or equal to 1, bracket greater than 1. Everyone with me so far? How do I create the union of these two? Just like before, I'm basically superimposing this guy on top. Come on, don't mess up now. There we go. On top of this guy. And wait a second, Mr. Morrow. There's no overlap here. Should there be an overlap with an or? No. What I have now is a system of a union here. Because I now have x is less than or equal to negative 2. Those are valid. Or x is greater than or equal to 1. That's valid as well. So how do I... Yes, sir. An or will never have an overlap. Correct, my brother. And an and will always have an overlap. So how do I graph this, straight up? Because, again, I can't move around my graph on paper. Well, x is less than or equal to negative 2. Or x is greater than or equal to 1. Ding dong, the witch is gone. Does that make sense, my brothers? Now, usually, they're going to write for you or compound inequalities like this. For some reason, they like to have the or, but they don't always have to. It looks a little bit weird, but notice the difference here. Do you see here how x is greater than both values? Okay? So what? Actually, that's wrong. That's wrong. That's wrong, that's wrong, that's wrong. This should be less than or equal to. Okay. So again, you read it from the variable. And this is wrong. X is less than or equal to negative 2. Or greater than or equal to 1. This is not the usual way to write or inequalities, though. They are usually written like this. X is, and again, this is wrong, x is less than or equal to negative 2, or x is greater than or equal to 1. Sorry about the mistakes there. Does that make sense, my brothers? Pretty easy, right? Does anyone have any questions before we actually start applying this? Because we got a good amount of examples. We're good? Okay, thank you. All right, let's do this. What compound inequality represents the phrase and then graph the solutions? So I want all real numbers that are, man, what is wrong with my typos today? That's a greater than, not then. Sorry about that. All real numbers are greater than -2 and less than 6. Always start with your x in the middle. X is greater than -2 and less than 6. Did everyone see how I magically did that? I just read, my brothers. I just read. Now, for graphing, you know I'm not going to make your life miserable. Put a 0, put the -2, put a 6, literally. You don't have to count out all the numbers. The concepts here are what's important. I know you know how to go 1, 2, 3, 4, 5. I know you know how to do that. But you don't have to. Just put the -2 and the 6. X is greater than -2. So I'm going this way. And it's less than 6. Why did I put an open circle? Sorry, that's from my Algebra I class. Parentheses. It's greater than -2. And it's less than parentheses 6. So it's everything in between -2 and 6. That's the intersection. Does that make sense, my friends? All real numbers are less than 0 or greater than or equal to 0. Well, in this case, this is an or to 5. So this is an or, all right? So I don't need to combine them. I can, but I don't have to. So I'm going to show you both ways you could do it. X is less than 0 or greater than or equal to 5. Or you could do this. X is less than 0 or X is greater than or equal to 5. For the ors, I will give you freedom. You could do either one. For the ands, since they're usually written as one inequality, I want you to practice that skill. Who knows, maybe on a test or a quiz, I'll ask for both types, and maybe I'll give you extra credit. Who knows? Maybe I won't. You should know how to do both ways. We're good? All right, now the fun part. I know, I'm a little bit of a dork, but that's okay. The fun part is solving for these compound inequalities. Now, pretend just for 1 second that this was gone. How do I solve that inequality? I add 4 to the right, right? Basically to both sides, right? My brothers, it's exactly the same, but this time you add 4 to every side. See what I just did there? So now I have 1, I have an m because the 4 is canceled, and I have less than 3. I'm done. Here's my 0. Always put your 0. 1, 3. M is greater than or equal to 1, but less than 3. Have a good day. Bam. Does that make sense, my friends? Sure, thank you. The one on top, oh, yeah, I guess we should have graphed the one on top. I apologize, son. Here's 0, here's 5. X is less than 0, and it's greater than or equal to 5. I'm sorry, my brother. Thank you so much for that. Does both example 1b and example 2, do they both make sense to you guys? Sir, thank you. Wait a second. Man, I am making all sorts of mistakes today. What is wrong with me? That's a -7. Oh, so I didn't do anything wrong. Okay, go ahead. What were you talking about?
For example, P, the top 0 is less than x, and x is greater than or equal to 5. I want the arrow.
X, okay, all real numbers that are less than 0. X is less than 0. Less than 0. or greater than or equal to 5. Greater than or equal to 5. You read from the variable. The all real numbers is your x, buddy. X is less than or equal to 0. X is less than or equal to 0. You read from the variable always. Thank you. Great question. From the variable always. Great question. Thank you, my brother. Does that make sense? Next. Okay, I want to solve for y. Easy. Add 4 to everything. Then I got to get rid of multiplication with division to everything. Bam, done. My 0, here's my 2/3, here's my 6. I'm not going to make this difficult for you guys. Y is greater than 2/3, but it's also, and it's less than 6. Does that make sense? We're good? Yes, sir. Yes, sir. Oh man, you are so good. Let's do that right now. Let's just make one up. Great job, kid. Great freaking question. My boy asked this. Let's say it was like this, Mr. Small. -5 is less than negative whatever 2y plus 6, and then I have here 18. Whatever. It's probably gonna be really ugly, but whatever. Subtract 6 to everything. -11. I got my -2y. I got my 12. Now, what my boy asks is, what happens when there's a negative? What happened before when there was a negative? You flip the sign. So yes, it is still valid, my brother. So this is not going to be y. This flips to whatever, 5.5. This flips to greater than or equal to -6. Here's my 0. Here's my -6. Here's my 5.5. Y is less than 5.5, but it's greater than or equal to -6. Bam. Well done. Great question. Well done. Does that make sense? Okay. Okay. I know your favorite. Word problems. I know you're excited. To earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. Inclusive means in between. When they say inclusive, that means in between. So they want, for you to get a B, you have to have between an 84 and an 86, unrounded. Okay, so you can't have an 83.9, and it can't be an 86.1. It has to be between 84 and 86. You with me? Okay. You scored 86, 85, 80 on the first 3 tests of the grading period. What possible score can you earn on the 4th and final test? That's not the 4th, and then there's another final test. It's the 4th and final. It's the last test to earn a B in the course. A couple things from middle school. Do you guys remember what your average or your mean equation was? What is it? Sum over number of values. Very good. Well, my brothers, don't we want to get between an 84 and an 86? Right? I know you want to get 100, but this particular guy, he's shooting low. So what is my value here in the center? I have an 86 plus an 85 plus an 80 plus my 4th and final test divided by 4. I want this value. It has to be greater than or equal to 84 or less than or equal to 86. Do you see what I did before I do any math? Everybody, you see that? You understand it? It's clear to you? You can see it. You understand how to do this even without me here. Sir. Why would I put the 86, not the 84? Because remember, I always go from lowest to largest. I want my average to be greater than 84 or less than or equal to 86. Because all I want is a B. So I need my grades inclusively between 84 and 86. Does that make sense, my man? Thank you, sir. Now, how do you think we solve this? Thank you. Thank you. Old skills coming back to haunt us, like always in math. So that's going to be 320, 336. That 4 cancels with that. Okay, 80, 80, 80 is 240, and 11, 251. And less than or equal to 320 and 24, 344. Now, subtract 251 to both sides. And x better be, your fourth and final test better be greater than, you got a 5, that's 13, yeah, 85, or less than or equal to 93%. And that is the range that you have to get on this last test for you to get a B. If you go over 93, you're going to get higher than a B. If you go lower than 85, you're not going to get a B. Sir?
If you go, you want us to graph?
Of course you can graph these word problems. I told you I made this very easy. 0, 85, 93. Yes, I know you said, do I want you to, and I just finished saying, yes, I want you to. Thank you, sir. Does that make sense, everybody? Awesome. Thank you for your awesome questions. All right. Let's move on. Now let's show you what ORs are like. With ORs, it's a lot easier. Because the ANDs, they combined everything. The ORs, seriously, they're separate, bro. 2 different equations. It's this or that. Not this and that. Okay? So here, subtract 2. And yes, I'm going fast because this is Mickey Mouse. I know you know how to do this. I'm not even explaining what I did. If I have to explain what I did, I'm sorry, you guys need to review. I will say, remember, I divided by a negative. It's not to a negative, it's by a negative. So boom, right here. I got my negative 3, and I got my 1. X is less than 3, negative 3. X is greater than 1. Ping, pong, boom, done. Bye-bye. Talk to me, all right, brothers. It's good? You think that's a lot easier than the other one? Well, yeah, I mean, I don't want you guys to think that this is hard, though.
Less work.
Ah, that's a better way to say it. Less work, yes. I think that they both are equally easy. I'm sorry that I'm coughing, guys. I have a bit of a cold, so I'm sorry. It's kind of annoying. May I continue, my brothers? All right, let's do this. It's an OR, so it's separate. -7. Like I said, I'm not trying to be tough. I'm just getting through this. I know that you know how to do this. If you don't, please ask me questions or review your old skills. Okay, so there you go. I got my solutions. Always put my 0, please. Y is less than or equal to -2, bracket to the left. Y is greater than 3, parentheses to the right. Not bad, right? Okay, I got 2 more that are going to be just a little bit more complicated equations, but it's still, I think, Mickey Mouse. May I continue? Thank you. All right. Okay. First of all, we got an or, right? We got an or. And we got an or. Okay. So, sorry, I had a little brain fart there for a second. All right. So let's go ahead and I can distribute, but what would be the wiser thing to do? Multiply by the reciprocal. Right? If I multiply, or, you know what though, but then I have a fraction. Yeah, let's not multiply by the reciprocal. Let's just multiply by 4. Yeah, let's get rid of that. Yeah, that's way better. Way better. So now I have 3x plus 12, because I got to distribute, is less than or equal to 4. 3x is less than or equal to negative 8. 3x is less than or equal to negative 11. Over here, multiply by that 2. What? Whoa, whoa. See what happens? I don't know. I get mad at you guys when you do that all the time. And what did I do? Exactly what I told you not to do. I apologize. That was completely unacceptable. Pay attention. Sorry about that. Thank you guys. Great catch. 3x plus 3 greater than or equal to 30. Now you subtract the 3. Bam. So my solution, negative 8/3, that's negative 2 2/3. So negative 1, negative 2, negative 3, negative 2 2/3 is like about here. So that's going to be a bracket. It's less than or equal to. And then over here we'll do my 9, greater than or equal to the right. Does that make sense? Now, sometimes, this is very rare. This is rarely going to happen. But sometimes they're nice to you. And instead of giving you one compound inequality already, they'll give it to you with an and. Just remember, ands are intersections. So if you do an and it looks like an or, you messed up. Excuse me. Let's do it. Negative 3, negative 3, negative 8x, less than or equal to negative 8. X is greater than or equal to 1. Divided by the negative 8. Then over here, 2/3 x is less than or equal to 2. Multiply by, actually here I could multiply by the reciprocal. X is less than or equal to 3. So here, my 0, my 1, my 3. X is less than or equal to 3, but it's greater than or equal to 1. And yes, that's an intersection. That's an and. Yes, sir, my brother.
For the second part, I got x is 4. It is less than.
No, it's not 4.
If you times the 3, I don't get
Times a 3. No. I subtracted 1,
yeah, but
which gives me a... No, you undo addition subtraction first. You undo addition subtraction first. No, for sure. There's not even a question in my mind, guys. You undo addition subtraction first. You subtract 1 to both sides first, then you undo addition, multiplication, division. Remember the two-step equation? Yes.
I did it. I multiplied everything by the negative first.
Okay, yeah. If you want to get rid of the fraction, you can multiply everything by 3. Okay. Then you're going to get 2x plus 3 is less than or equal to 9. Right? Subtract the 3. 2x is less than or equal to 6. X will still be less than or equal to 3. Okay, you confused me. You can get rid of the denominator, but no, to solve, you cannot multiply by 3. And then, no. Undo addition subtraction first. No worries. Thank you, my brothers. Thank you. Does that make sense? We're golden. Have a great day. Thank you very much. Hope you learned a